Hello and welcome to this episode of the Industrial Engineering Notebook. Today's topic is voltage and current. A lot of times industrial engineers complain about having to learn about electricity and circuits and all that stuff, but the fact of the matter is every factory has many electrical systems. As industrial engineers, we need to be able to analyze those systems, and we need to be able to speak intelligently with electrical engineers. We're going to start by looking at the atom. In particular, we're just going to look at the simple example of carbon-14. Maybe you've heard of it. One atom of carbon-14 has 6 protons, and those protons are positively charged. Carbon-14 has 8 neutrons. Neutrons have no charge. And carbon-14 has 6 electrons, which have a negative charge. The first 2 of those electrons are in a stable orbital around the protons and the neutrons in the atom, and the other 4 are on the outside. And out here, these 4 electrons are free to roam and make chemical bonds, things like that. And the electrons on the outside are called valence electrons. Going back to charge can be positive, it can be negative, you can have no charge, you can have lots of charge, you can have little charge. But the key takeaway about charge right now is that you measure the amount of charge in the unit coulombs, which is just abbreviated with a capital C. So each proton has a certain number of coulombs of positive charge, and the electrons have a negative amount of charge in coulombs. Now we're going to look at the copper atom. Cu is the abbreviation for copper. And let's say all the protons, the neutrons, the electrons in stable orbitals are all in this little circle here. And copper has only one valence electron, which I'll draw here. So only one electron that's free to roam. And in a copper wire, you're going to have a whole bunch of those valence electrons, one for each atom of copper that you have. So let's say one day you're bored and you decide to start putting a bunch of positive charges over here, and then you put a bunch of negative charges over here. What is going to happen to the electrons in those copper atoms? Well, opposites attract. Positive charges want to move towards negative charges and vice versa. So the negatively charged electrons will start pushing their way through the copper atoms to escape the negative charge and move towards the positive charge. And we would call this flow of charge through the wire current. And it turns out that negative charge moving in this direction is the same as positive charge moving this direction. And actually, this is the standard that we use for current. We show current flowing from positive to negative, even though we know the electrons are flowing the opposite direction. But the math all works out the same, so don't worry about it. Someone messed it up like 200 years ago. It's fine. So the current is the flow of charge from positive to negative. It's kind of like the speed of the charge. So if you look at one point in the wire and you see how much charge per unit of time flows past that point, then you can get a measure on the amount of current. So current is just charge per unit time. The units on this are coulombs per second usually, or amperes, sometimes called amps for short. Charge per unit time, not time. That is an M. Okay, so what is voltage then? To understand voltage, we're going to look at a block sliding down a ramp. So over here on the ramp, the block is starting at position A, and we want to know if it's going to slide down to position B. And one way to show that it will is to recognize that position A has more height than position B, which means it's got more potential energy. Let's say it's got 5 joules of potential energy. But if this block were at B, it would only have 3 joules of potential energy, because some of this energy would have been converted to kinetic energy to slide down the ramp. So we say, yes, this block will slide from A to B because there is a difference in potential energy between the points. And then looking over here where there is no incline, there's no height difference between A and B. Maybe the potential energy at A is 4 joules relative to the ground somewhere down here. And the potential energy at B is 4 joules. And I guess the ground would be somewhere down here as well for this ramp too. So will this block slide? Yes, because there's a difference in potential energy between the 2 points. Will this block slide? No, because there's not a difference in potential energy between the 2 points. You would need to apply an external force. But it will not be sliding because of a difference in potential energy. And so for a wire, and maybe one end of the wire is point A and the other end of the wire is point B, if one end has a higher electric potential energy than the other end, then charge will flow. So if A has high potential and B has low potential, then the current's going to flow this way. And we measure electric potential with, you guessed it, voltage. So voltage is just electric potential energy. We measure this in joules per coulomb, which is the same as volts. And if there's a voltage difference between 2 points on a wire, that charge is going to flow. If there's no difference, no charge flows. So this is voltage, and we already discussed current. We usually use the variable I for current and the variable V for voltage, or sometimes these are lowercase. But these are the two most important variables in electric systems. You can write all kinds of fancy equations with these, and if you have a good foundational understanding of this, you will have a better understanding of the machines in your factory and maybe even how to improve them. If you like this video, hit the like button. If you want to see more videos like it, please hit the subscribe button. If you have questions, feel free to put them in the comments and I'll do the best that I can to answer them. Thanks.